Hey, this is Mr. Aiden. This is AB Calculus AB. We're going to be differentiating inverse functions. Inverse functions, which means we got to know what an inverse function is. If you remember back to Algebra 2, if you remember back to Algebra 1, if you remember back to pre-calculus, if you don't remember that at all, just stay on tight. An inverse function. What is an inverse function? It's a function that is going to be the reflection of this function y equals x. Okay, so it's the reflection of it, and you can see how this guy has a positive, very positive slope. This one still has a positive slope, but it's not as steep, is it? Okay, and so what do we know about inverse functions here? Is inverse functions, let's just say that we have a function of f of x, okay, and let's say its inverse is g of x. G of x is the inverse of my f of x function. Now, when I put g of f of x, if I put this function into the inverse function into the other one as a composite function, I end up getting x, which means when we want to find the derivative of the inverse function of g of f of x, you can see the chain rules right here, it's the same as the derivative of x right here, which ends up becoming, when you do all of this, the derivative of this inverse function ends up becoming 1 over g prime of f of x. Now, this doesn't mean anything to you, and I'm okay if it doesn't mean anything to you, because in college, I remember I developed this little shortcut method, this little tabular method, and it works every time. My calculus students over the last couple of years have done this, and in every single problem, it helps them work it out. So I want to give you that example of a little bit of a shortcut to find inverse functions. You can see right here, I have the function y equals x squared. So I'm going to call that f of x equals x squared. That's going to be what I'm going to consider my inverse, my parent function. My inverse function of that, which I'm just going to call g of x if that's okay, that's going to be equal to the square root of x. And you can see the green one is my x squared, that's my parent function. My reflection is going to be the inverse function of this g of x function, this square root of x, okay, to find that inverse. So let's just take a point like 3, okay, so f of 3. What's f of 3? That's 3 squared, that's equal to 9, which means if you do inverse functions, if I come back to this guy right here, you can see at 2, this green guy gives you 6, okay, so you can see we have 2, 6 right here, which means at 6, we're going to be at 2. It's a reflection of each other. So at 2, 6, the inverse is going to be 6, 2. You can see the x and the y are swapped right there. So when I get f to the negative 1 of 9, which is the inverse function of 9, g of 9, we get the square root of 9, which is 3. Hopefully you can see when we plug 3 into my parent function, I get 9. When I plug 9 into my inverse function, I get 3. It's very synonymous with 2, 6. And in the inverse, it's 6, 2. So plug 3 in for x, we get 9, which means the inverse is always going to be the opposite. We plug 9 in for x, we get 3, which means now we can do the derivative. The derivative of this f function, what's the derivative of x squared, is 2x, which means the derivative at 3 is equal to 2 times 3, or 6. So let's take a look at what happens when I take the derivative of my inverse function. So the derivative of my inverse function at 9 is the derivative of the g function at 9. What's the derivative of the square root of x? Is going to be 1/2 x to the negative 1/2, or 1 over 2 the square root of x. So you plug in 1 over 2 root 9, and you get 1 over 6. I hope you can see what just happened there, and you're like, I have no clue what just happened there. So when f of 3 equals 9, the inverse, g of 9 equals 3. They swap with each other, which means the derivative of the function is equal to 6, which means the derivative of the inverse function is equal to 1 over 6. When he was 6, he was the reciprocal 1 over 6. And it works out every time like this. Let's say we have f of a is equal to b. And let's say the inverse function, f and g are inverse functions. That means g of b equals a, which means f prime of a is equal to, let's say, a different number, c, which means g prime of b is equal to 1 over c. It's going to be the inverse of it. So this little tabular thing works out every time. My students do it over and over and over again for inverse functions, and they love it because it's so stinking easy. Let me give you an example. We have g and h, they're inverses of each other, which means what do we know? We know g of a is equal to b, and we know h of b is equal to a. It's going to be swap with each other. So I want to take a look. Is there two numbers in here that kind of match up a little bit? And you can see it's a 0, isn't it? Okay, so you can see g of 0 is equal to -2. You can see that with my table. When I plug 0 in for g, I get -2, which means h of -2 must be 0. And look, h of -2 equals 0. It confirms it, doesn't it? Which means g prime of 0, that's what I'm looking for. I'm looking for g prime of 0, which means I can look at what's h prime of -2. Let's look at my table. H prime of -2 equals -1. So that must mean g prime of 0, the inverse, is going to be this -1 reciprocal, 1 over -1, which is -1 as well. And so that is finding the derivatives of inverse functions. Thanks, guys.